All right, hello. This is a video for Unit 14, Day 2, Probability Day 2. I'm going to start with a warm-up here, so just read through this quick. We got an experiment, has two parts. First, toss a coin and note the outcome, and second, roll a six-sided die and note the outcome. Part A wants us to write a set of ordered pairs, such as H4, represents all outcomes for this experiment. So H4 would obviously mean you flip a coin and get heads, and then you roll a 4 on the die. Recall that this is called the sample space S. Okay, so for our sample space, or S, we are going to have, let's do all the heads first. It helps to do this kind of in a methodical manner here. So we'll do heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, and heads and 6. Then we'll do tails and get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. Okay, so there's our entire sample space. Next, part B says, write the set of ordered pairs that represents the event of getting a tail and an even number. Let this be defined as set A. So in set A, we just want the ones that have tails and an even number. So that would be T2, T4, and T6. Part C, write the elements of A. Remember, this means A complement. And we're going to call this set B. So A complement means everything that's not in set A. So I want everything in that sample space, in this S up here, that's not in that set A that I just wrote. So set B, which is really A complement, is going to be everything except T2, T4, and T6. So that will be H1, H2, H3, H4, H5, and H6, and then T1, T3, T5. Okay, now when you see this P in front of them, remember that means the probability of. So I want the probability of getting something in set A. So probability of getting a tail and an even number. So I can just count. There's 3 of those. So there's 3 ways to make that happen over the total number of things that could happen, which is your sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 out of 12. Then we always want to do simplest form. So that's going to become 1 out of 4. So you got a 1 out of 4 chance. Probability of B would be the probability of not getting a tail and an even number. So look at all the options in set B. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to equal 9 out of, again, all those 12 original possibilities. And that will reduce to 3/4. You have a 3 out of 4 chance of that happening. The last one's kind of weird. It's just the probability of the sample space. And that's just all outcomes. So the probability of tossing a coin and rolling a 6-sided die. Well, there's 12 ways to get that out of a total possible 12 ways. It means that's probability of 1. Okay, so as a side note, whenever I ask for the probability of the entire sample space, PS, that's always going to equal 1. So that means it's definitely going to happen. So probability of S equals 1 always. So this last thing we're going to talk a little bit more about in class today. What is A? Remember, this symbol means intersect B. That means how many elements or what elements are in A and B. Okay, well, in A, we've got T2, T4, T6, and none of those elements are in set B, so there's nothing in the overlap here. So that means this is nothing, or the empty set. That means there's nothing in that set. Or you can write it as an empty set of brackets. That means the same thing. Now that should always be the case. The intersection of A and its complement is always going to be nothing, because literally A complement means everything that's not in A. So if everything's not in A, there's going to be nothing that's also in A. And if you want to see your random fact of the day, bats always turn left when exiting a cave. It's true, don't know why. All right, next up, let's switch over to the notes. The notes, we've got, should say Unit 14, Day 2, more sets and probability. Now, if you knew you were going to miss this day, you should have a copy of these notes that I gave you. So I would suggest filling these in as I go through them. If you didn't know you were going to miss, if you go to my website, right before this video link, there should have been a link that said download a blank copy of the notes. So if you want to download and copy and print those off, so you can fill those in, maybe pause the video so do that quick. But if you're ready, here we go. First off, what is a set? A set is just a collection of elements from well-defined criteria. So just like the things in the warm-up, those sets were well-defined. We said we want a set of getting a tail and an even number. That's pretty specific and well-defined. An element is just a thing contained in a set. So again, going back to the warm-up, for example, tails and 2 was an element of that set A that we talked about. All right, so you're just going to see those words come up in problems, and that's all they mean. Nothing too crazy. So here's example 1. Set W is defined as the collection of all integers that are greater than 0 and less than 10. Write out W in roster form. So that just means write it out as a list. So integers are whole numbers that, no fractions, anything like that, greater than 0, less than 10. So we're going to get 1, 2, 3, 4, 5, 6, 7, 8, and 9. B says show set W with a Venn diagram. This is a little bit weird. So this is set W. And in this case, normally you think of Venn diagrams. You did those a lot back in middle school probably, as maybe being intersecting circles. We'll get to that later. But right now we just got one set, and we just put everything that's in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. C says define a set C that is a subset of set W. Now remember from yesterday, subset just means it contains some elements of set W. Maybe it contains all the elements, but it contains at least some elements. Then list the elements in set C. So we have to define it first. So let's make set C, I'm just making this up, there's lots of different ones we can do. But let's define set C as all odd numbers greater than or equal to, let's just say, greater than 0 and less than 10. All right, so that means C would equal 1, 3, 5, 7, and 9. I could have also said all even numbers. I could have said multiples of 2. I could have said multiples of 3. I could have said multiples of 4. I could have done anything. Just any set that whose elements are all contained within here. Part D, what is the intersection of W and C? So that means W intersects C. Explain why the answer should be the same regardless of the subset you created in part C. All right, well, let's first look at what the intersection is. Remember, intersection is what's in both. So 1's in both, 3's in both, 5's in both, 7, and 9. All right, but that means that that's just what? That's the same as set C. So in the end here, we've got that W intersects C. is really just equal to C. Now, if you can think of why that would be, well, it should make sense. We want the things that are in both. Well, C was a subset, meaning everything in C was also in W. So in the end, the entire set C is going to be the intersection because everything here is also in the original. So if I was going to explain it, I could say the intersection of a set and its subset always equals the subset. Because those elements are in common. All right, this has already come up in the warm-up, but empty set. I mentioned that you could write an empty set as 0 with a slash through it, or is just an empty set of brackets. And the empty set is really just a set with no elements. There's nothing inside. Pretty self-explanatory. All right, so next up, example 2. Draw a tree diagram that represents all outcomes in the sample space of rolling 2 4-sided dice. Okay, so we talked a little bit about tree diagrams yesterday, I think. Remember what that's going to look like. 2 4-sided dice. So let's do our first roll here. Now, normally we think it's a 6-sided dice, but here's only 1 through 4. So on my first roll, I could get a 1, a 2, a 3, or a 4. So that was roll 1. And in my second roll, I can also get a 1, 2, 3, and 4. So this 1 could go with a 1, 2, 3, 4. Same with the 2. 1, 2, 3, 4. And the 3. 1, 2, 3, 4. And the 4. 1, 2, 3, 4. Kind of ran out of room there. Okay, so maybe it's easier to like list out the subset looking at these different trees now. So you just want to kind of read straight across. So 1, 1 is going to be one of them. So we've got, call this S, the sample space. We've got getting a 1 and a 1. And then just keep following out these different trees. So next is 1 and a 2. And then 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. Finally, 4, 1, 4, 2, 4, 3, 4, 4. So now that makes how many outcomes are there pretty easy. Just count. Well, we got 4 rows of 4, so 16. Now, something we're not really getting into this year that we could, this is kind of a long, drawn-out process, could just do the counting principle. The first time I rolled 4, I had 4 options. The second time I rolled the die, I had 4 options. 4 times 4 is 16. That's not a coincidence. But anyways, don't worry too much about that this year. All right, part B. What's the probability that you do not get 2 of the same number? Well, the only things I don't want are what? I don't want 1, 1. I don't want 2, 2. I don't want 3, 3. And I don't want 4, 4. So how many are left? Well, there were 16. I don't want those 4. So now there's 12 possibilities out of the 16. is equal to 3/4. Now, in that case, it was kind of easier to count the ones I didn't want instead of the ones that I did want. So just as a side note, if I'm looking for how many do not have the same number, I could always calculate 1 minus the probability that they do have the same number. That's a trick you can always use. If it's easier to count what you don't want, then 1 minus these 4 out of 16 gives me that 12 out of 16 number that I need. So that might save you some time sometimes. Then finally it says, what is the most likely sum of the dice? What is this probability? Well, this is when it really helps to have the sample space listed out, which we've got up here. So now let's look at the sum here. I'm just going to write the sums of all of them. So the sums of 1, 1 is 2. 1, 2 is 3. 1, 3 is 4. 1, 4 is 5. The next row of sums would be 3, 4, 5, 6. And then 4, 5, 6, 7. And then 5, 6, 7, 8. So those are all my sums I can get. Now take a look there. What number in that bunch shows up the most? Well, the only number that's in every row is a 5. So the most likely sum is the same as saying what's the probability of getting a sum equal to 5. So the probability would be 4, namely these 4. 4, 1, 3, 2, 2, 3, 1, 4. Out of how many possibles? That's the number in the sample space, 16. So that reduces to 1/4. You have a 1 in 4 chance of rolling a 5. All right. Those were a little tedious, but hopefully not too difficult. On the next page, we're going to review some Venn diagram stuff. So if you're not quite ready, pause the video. But if you're ready to go on, here we go. All right, we've got an online bookstore offers a large selection of books. Some of the books are works of fiction and some are not. Also, some of the books are available as ebooks and some are not. Let F be the set of books that are fiction, and let E be the set of books that are available as ebooks. And the Venn diagrams provided shade the regions representing books that are available as ebooks. So this is a little bit vague. It doesn't say only available as ebooks. It just says available as ebooks. That'd be everything in the E circle. So everything in this E circle, whether it overlaps or not, would be available as an ebook. So that's the answer for that one. Second one says not works of fiction. Anything in this circle, the F circle, are works of fiction. So I can't go inside that circle at all, but I can go anywhere else. That includes in this box here. So I want to shade everything except inside that circle. C says works of fiction and available as ebooks. So they have to be in the F circle and in the E circle. That's where we overlap in the center here. And finally, works of fiction or available as ebooks. So it has to be in either the F circle or the E circle. That doesn't mean exclusively or. So that means it could be in both circles. So that's everything here. As long as it's in one of the circles, maybe both, doesn't matter, it's available as fictions or ebooks. Now if it said works of fiction or ebooks exclusively, then maybe we wouldn't fill in that center, but don't worry about that. These last two down here, neither works of fiction nor available as ebooks. It can't be in either circle. So that means we're everything outside both circles. Something like that. And lastly, works of fiction that are not available as ebooks. Now, if it just said works of fiction, it'd be everything in this F circle here. But this one's more specific. It says works of fiction and specifically not ebooks. So you got to be in that fiction circle. But you can't be in the E circle. This is when we don't include that overlap. So it looked like that. All right, now that quick review of Venn diagrams, I know you've seen at some point in your life before, hopefully, is going to help us with some probabilities moving forward. So let's move on to the next page and do a probability with Venn diagrams. It says when a fish is selected at random from a tank, the probability that has a green tail is 0.64. I'm just going to write up here, probability green equals 0.64. Probability that has red fins is 0.25. Probability of red is 0.25. And the probability that it has both red and green is 0.19. I'm going to write that as green and, or intersect, red equals 0.19. Part A, draw a Venn diagram to represent this information. All right, so you want to have a box. And then in that box, we only have two scenarios here. We've got green fins, G, or red fins, R. Now, the first thing you should always do is this intersection. If you have that, plot the intersection. So I'm going to say plot or label intersection first. So right here, we've got 0.19. Now, here's the big mistake people make. Don't do this. Probability of green is 0.64. That does not mean that 0.64 goes there. Anyone know why? Well, that means the probability that you're in this G circle is 0.64. That also includes this 0.19. So rather than put 0.64 in here, I'm going to make a note out here. The total of green circle must equal 0.64. I've already got 0.19 in there. So what goes in that other section? Do 0.64 minus 0.19, and you'll get 0.45. That's what ends up right here. That 0.45 then is just in this section. But then if I look at the entire circle together, I have 0.64 in that entire circle together. All right, lastly over here, probability of green was 0.25, but again, I've already got 0.19 counted for. So in this circle here, I can say that the total of the red circle has to be 0.25. So take 0.25, take out that 0.19 that's already accounted for, you're left with 0.06. That means the probability of just exclusively a red tail without a green, or a green red fin without a green tail is 0.06. Now, there's one more thing you fill in. You have to know what goes on the outside. So this is probabilities. And we said probabilities always have to add up to what? 1. All possibilities have to add up to 1. So on this outside here, there's going to be some possible fish that don't have green tails or red fins. And the way we find that is by knowing that fact. The total of all probabilities has to equal 1. So if I do 1 minus everything I have, so minus that 0.45, minus that 0.19, minus that 0.06, I end up with what should be out here, which is 0.30. So that means the probability that it doesn't have those two characteristics is 0.30. All right, so there's my Venn diagram, and that's kind of the strategy you want to take every time you work with Venn diagrams. So now down here, find the probability that the fish has red fins but does not have a green tail. So red fins means we're in the red fin circle, but then not green tail means don't encroach on that green tail circle at all. So to be in that circle but not in the green circle at all, the probability of that is just 0.06. Next up, a green tail but not red fins. Well, same idea, but just from the other side now. You want to be in the green tail circle, but not in the red fins. So don't encroach in this red fin section. The only thing left is that 0.45. And then part 3, neither a green tail nor a red fin. That means I'm not in either of these circles, and the only number that's not in any circle is this 0.30. This is 0.30. Those are probabilities, the probability of all of those. Okay. Last part for this question says, complete the table below showing the possibilities of the events corresponding to the cells of the table. It's kind of annoying, I'm going to have to keep flipping up here. But what would go in this cell here would mean if I have red fins and a green tail at the same time. Red fins and green tail was that intersection, so this would be 0.19. Let's go across. Red fins but not a green tail. So red fins but not a green tail. We did that already. That's just the 0.06. When you total these, 0.19 plus 0.06, what do you get? You get 0.25, which corresponds to having just red fins. I shouldn't say just red fins, but having red fins. We said the probability of having red fins was 0.25. Next one. Not red fins, but does have a green tail. So we did that a second ago. Not red fins, green tail. Is this piece all alone over here, 0.45. Not red fins and not a green tail. Well, that's going to be neither. So that's 0.30. When you add these, we get the probability of not having red fins, which is actually 0.75. Now, if you total down 0.19 plus 0.45, that was 0.64. And that should look familiar because we said the probability of having a green tail up at the top here was 0.64. Probability of not having a green tail, 0.36. And the interesting thing that should always happen in this corner here is if you add across these columns and add down these columns, you get 1. And that's because if you either have a red tail or not have a red tail, or have a red fin, or have a green tail or not have a green tail, you have to be either or in both of these cases. So that means total probability of that would be 1. All right. One more of these on the last page. So flip over to the back and we'll finish this off. Now think about cars available at a dealership. Suppose a car is selected at random from the cars at this dealership. Let the event that a car has manual transition be denoted by M, and the event that the car is a sedan be denoted by S. The Venn diagram below shows the probabilities associated with 4 of the regions of the diagram. So I've got the whole Venn diagram filled out for me. That's kind of nice. So now we got to interpret it. Part A, what is the value of M intersect S? That means where do these have a manual transmission and be a sedan? So what do you think that would be on the Venn diagram? That'd be where they overlap. So right here. So this is just 0.12. Complete the sentence using and or. Probability of M intersect S is the probability that a randomly selected car has a manual transmission and is a sedan. So the intersection essentially means and. And that should make sense because that almost looks like an A that you just forgot to cross. So this is always, intersection is always going to be and. Okay, then C down here. What is the value of M union S? This one's a little bit tricky. Needs to have a manual transmission. Everything that has a manual transmission and everything that's in being a sedan. Well, I would just add up anything in either of these circles. So that's 0.09 plus 0.12 plus 0.6. I end up with a probability of 0.81. I was careful how to read that union because I didn't want to give this other one away. You can probably guess, though. Probability of M union S is the probability that a randomly selected car has a manual transmission or is a sedan. And or is what I think messes people up usually. Or is not an exclusive or. So that means it might have both. That's why we included this 0.12. But it does have manual transmission or it is a sedan. At least one of those is true. Maybe both of those are true. Okay, so union always means or. What's the value of SC? It means S complement. Remember, complement means probability that you're not a sedan or not in circle S. So you want to look up at that Venn diagram and find everything that's not in that circle S. Well, that's this one or that one out here. Just can't be anywhere in that S. So not a sedan. So we've got 0.09 plus 0.19 means the probability of not being a sedan is 0.28. And finally, explain the meaning of probability of S complement. Kind of talked about that already. That's just the probability of not being a sedan. All right, and that's the end of the notes. So give the homework a shot. You should have that as well if you knew you were missing. If not, you can print out a copy from my website. And don't forget, you also have a Green Book assignment tonight. So be looking over those questions on the Green Book because those are also going to be due as soon as you're back. That's it. Thanks and good luck.